Let's consider how we can best support students as we teach them to think like scientists using argumentation. Science is truly a part of our real-world experience every day. So what does science really entail? Well, we explore the world around us. We want to be able to explain the world around us. And to do that, we need to be able to articulate our thinking, our evidence-based thinking, in writing and speaking formats so that we can communicate with the world around us. This is what we need to teach students to be able to do. Let's consider some of the questions that we ask today as a society. Can genetically modified foods help solve world hunger problems? How can we solve the problems of ocean acidification? How can we design and construct buildings that will withstand strong earthquakes? And can we grow organs like kidneys in a laboratory setting to be used for transplants? These and many other questions that affect society and individuals every day are the basis for scientific investigation and ultimately for being able to communicate thinking in an argumentation format around the investigation. Let's consider a classroom example that might involve students engaging in argumentation. Well, first of all, students need to begin with questions. A well-developed, deep question can be so powerful in terms of being able to develop an argument. In one particular 8th grade science classroom, the teacher posed this question to students. On a wind turbine, what type of blades produce the most electricity? Students were asked to consider round blades, square blades, small blades, large blades that are angled at various degrees, like 45 degrees or 60 degrees. So in order to answer this question, they had to engage in an investigation. Within this 8th grade classroom, students in groups were asked to construct various types of blades. They used cardboard. They posted their blades onto motors so that they could spin, hooked them up to an electrical source, and used blow dryers to simulate the wind. So they tested various types of blades, round blades, large blades, short blades, blades that were placed at various angles to see which would generate the most electricity. So remember, that was the goal for students to answer that question, which is the best blade type to provide electricity using in the format of a wind turbine. So here's 8th grader Devon's response. Big blades give more electricity. They are bigger and are easier to turn when the wind blows. I have 2 toy wind spinners at home. One is big and the other is little. The big one spins more. For this reason, you get more energy, which is electricity. Taking a look at Devon's response, I'd like you to spend a few seconds thinking about what's good, what's missing, and if you were Devon's teacher, what would your next steps be? I'll pause for a few seconds for you to consider these questions. All right, let's come back together. Did you perhaps say that it's good that Devon is citing some evidence, including that he has 2 toy wind spinners at home? He is drawing on his background knowledge. However, that's not the kind of evidence that we're looking for. Devon actually conducted an experiment with his fellow students, and he had some data. He did a nice job of documenting his data in a data table format with some numbers and also some qualitative pieces, some descriptors. However, when he came to write up his analysis in response to the problem, he didn't cite that evidence. So while we appreciate that he is drawing some conclusions, he's not really building a case, a strong case for his conclusions. So if you were Devon's teacher, perhaps you might think that you would need to model a good response. you might consider offering sentence frames or sentence starters that would prompt Devin and his peers to be able to cite some more evidence, giving them sentence frames such as the evidence suggests blank because could inspire students to really consider the evidence. When we consider the elements that make for a good argument, the claim, which is the statement that the writer is making regarding an issue that might have various opinions or various responses. There's the evidence, which is the data that's collected that supports the claim. There is the warrant, which is the reasoning, the bridge between the evidence and the claim, the explanation. And in science, that is often rooted in scientific principles or scientific thinking, and we clearly don't see that. We also don't see Devin addressing any counterclaims. Sometimes the addition of counterclaims is appropriate, saying things like, while some might consider this, or there are varying views that present this other type of explanation. That could be appropriate, but it doesn't always fit with every type of argument that the student is documenting. So that is something to consider as well. If we look at Devin's response, he has a claim. Larger blades that are angled at 45 degrees produce more electricity. He shares his evidence. You can see that evidence right there. We talked a little bit about how he does have evidence, but it could be strengthened. He's missing the warrant, and he doesn't have any counterclaims addressed. Let's pause for a minute and ask ourselves, why do we want to help students to be able to use evidence? Well, we know in today's world it's important to communicate in a convincing manner, and that means drawing on scientific principles and using academic language to be able to share your understanding of a topic using evidence. When we ask students to use evidence in a classroom, they're getting to practice the 21st century skills of complex communication and problem solving. And we also know that students need to learn to evaluate evidence for claims in their everyday lives. All of us are inundated with claims that state this is the best diet product or this car is the most efficient. We need to be able to sort through those claims and really look for the evidence. So that's one of the things that we want to teach our students to do. Not only do students need to include evidence in their arguments, but they need to be able to develop substantial evidence. And what do we mean by that? Well, we know that students often rely on their own ideas or opinions. They don't always use the data they've collected. Students need to think about this. What claim makes sense given my evidence? Do I have enough evidence? Is it the right kind of evidence? Students need to look at all the data, not just focus on one data point that might prove their claim. They need to look at everything because possibly they may be revising their claim. They need to consider whether or not they have enough data. And if we go back to Devin's class, we need to help students look at all their data, size, shape, angle, because if they don't, they could be drawn to misguided conclusions. For example, Devin might have this, a counterclaim that discusses the effects of differing amounts of wind on the turbine. In Devin's class, students use blow dryers set on low and on high settings to change the amount of wind, but Devin neglected to discuss this. So the evidence needs to be substantial. When students author the warrant, they are articulating reasons why the evidence supports the claim. This is the bridge or connection between the claim and the evidence. It is clearly the most difficult aspect of an argument to be able to compose, but helping students to think about these questions. Why does the evidence support the claim? And what science concepts link my evidence to my claims can be helpful. Remind students that just saying the counterclaim is wrong is not sufficient. If students do this, they will often come up with inaccurate conclusions. They need to consider all possibilities. In one particular class, a group of students designed and constructed mousetrap vehicles. They tested different materials and concluded that wood was a faster material than plastic for the body. However, there were other factors that were involved, like size, shape of the wheels, the surface on which the car was running, lots of other things that could have had an effect. But by students just honing in on one aspect, they missed the bigger picture and the other areas of focus that they should consider. Because Devon's teacher was not satisfied with the analyses, the argument-based analyses that students were writing, she decided that it would be helpful to offer them a template. So you can see at the top there's a place for the students to record the question. There's a reminder to take a position. There's also a place for them to state what might be some other positions. And along those lines, below that, you'll see a place where they support their positions. They record different pieces of data that support their position, including the sources. They want to have credible sources. And then data that supports counter positions, along with the evidence for this and the sources for this. Devon's teacher wanted them to have something that would grab the reader. So she had a place for them to craft their hook, something that would pull the reader in, and then a place for them to reflect on the issue, their positions, and other possible positions as well. So this was a precursor to actually writing the argument. And this slide shows you a team of students working to build the best mousetrap car that they can possibly build. And in this particular classroom, these students were asked to build a mousetrap car, a car that uses the energy from the spring action of a mousetrap, to propel the car forward 10 meters, but then the car also had to reverse and go backwards 5 meters. Quite a challenge. In order to do this, they had to consider, what is the best way to build this car? But the slide here is just to remind you that these kinds of investigations in which you're looking at a problem and possibly trying to draw a claim from your investigation of the problem oftentimes occurs in a collaborative setting. And you want to mirror the real world collaboration that happens when scientists and engineers and researchers are investigating a problem within your classroom. So ask students to work in teacher-created teams. Let's pause for a minute so that you can think. Think about times in the past when you have engaged your own students in scientific explanation or in arguments in writing or orally. Or if you haven't had the opportunity to teach this, consider a time perhaps when you were a student and your teacher was asking you to write a scientific explanation or to develop an argument, either in writing or orally. What were some of the challenges that your students had if you were the teacher, or that you had with writing or talking about the data or the claims? What did you find challenging about incorporating scientific claims or explanations or arguments into a classroom or into your own experience if you were the student? Think about these things. And be sure to teach using modeling, practice, and collaboration, helping students to develop and write their explanations for argument in science. They need to have a claim, the conclusion or question to a problem, the evidence, the scientific data that supports the claim. They need the warrant, that bridge between the evidence and the claim that is substantial. And they need to address the counterclaims by acknowledging there are different ideas, considering these alternative ideas, and then ruling them out in favor of the ideas that they think are best, their ultimate claim. Many students think that scientific argument is really about winning a debate or having the right ideas. But in science in particular, it's more about understanding how phenomena occur, why they occur, using evidence to support and justify claims, and then developing the best explanation given the data to justify a claim that is rooted in an analysis of data. It's really all about the data, either looking at the data you've collected, as Devin did, or looking at the data that is collected by others. For instance, if a student were investigating ocean acidification, they might look at other research studies. So really, it's not about winning a debate. You consider all ideas and then develop a claim based on the data, reasoning, and a look at all the possible ideas. So let's again consider all the parts of a strong argument. We have the claim, which is the statement that expresses the answer or conclusion to a problem or question. You need to remind students to look at the problem or question and then to really respond to it specifically, because they need practice in doing this. Oftentimes they'll go off on tangents or areas that are related to the claim but not really about what the problem is asking. So be sure that they stay focused on this. Be sure to remind students and provide them with practice in understanding how to write about evidence. Evidence is really about scientific data that supports the claim. It can be derived from information, including observations and measurements from the natural world and laboratory settings as well. It needs to be accurate and reliable, oftentimes checked through multiple trials or by comparing different types of data. And it can be collected from other sources as long as they are credible. So that might mean using data tables or information about research from other texts or readings that students might be looking at, or it could be from databases that other researchers have developed and shared with the public. So help students to connect evidence to data, not to their personal opinion. Because evidence is so important, you need to help students really understand that evidence must be appropriate. Not all evidence fits with the problem. So they need to be able to look at evidence and sort through and see what's relevant. They need the right kind of data, specifically relevant for supporting the claim they are addressing. If we go back to Devin's response, in his first response, he said that he had wind toys that he observed spinning. While we appreciate that he is drawing on his own experiences, his own background knowledge, his evidence should be rooted in his data collection. That's really what we were looking for in his response. Later, we see in the revision that Devin uses data about blade size, blade shape, and blade angle as evidence for his claim. We also need to ensure that there's enough data. Oftentimes, one piece of data is not sufficient. This part's very difficult because it's hard to say for certain claims what is enough evidence. It really is up to the author of the argument to be able to determine that. The number of pieces of data really depends on the claim. Devin uses approximately 3 pieces of data to support his claim. That may be sufficient. It may not for this particular claim that he is making, but you can be sure that 1 piece of evidence is typically not sufficient. Again, the warrant is one of the most difficult parts of an argument to compose. The warrant is that bridge. It links the evidence to the claim, and it explains why the evidence supports the claim. It needs to be a logical connection between the claim and the evidence. Picking and choosing data depends on scientific principles, really. So if we go again back to Devin's response, he would have strengthened his response if he would have discussed the correlation between electricity and voltage. If he would have brought in that science understanding so that he could really clarify how he was connecting his evidence, the number of volts that he was determining using the voltmeter, with his decision on which blade is the most effective. He needed to show that there is a correlation between voltage and the electricity generated. The argument should be logical and, again, be rooted in a foundational understanding of science. When addressing counterclaims, students need to recognize and describe alternative ideas for the question or problem. This is really rooted in an understanding that scientists discuss and debate multiple possibilities. In some other content areas, this might not happen to as great an extent, but in science, we're always looking to see what is the best answer, what is the best option. So you have to consider multiple possibilities. In the scientific explanation, students should discuss the reason why the claim is correct and the reason why the counterclaim is not. They need to address both. To support your students to really develop strong arguments, you need to present them with the right real-world situations or the right questions. You want to be sure that you're connecting content to things in our global or local world. You want to ensure that the question allows students to collect or access data or research that is appropriate to the question. Not every question really fosters that ability or allows for that ability. Students need to be able to identify counterclaims, and really offering open questions tends to be best. If you consider these two options here, do steel wheels or wooden wheels work better for a mousetrap car? Or this other option, what's the best design for getting a mousetrap car to go forward 10 meters and then reverse to go 5 meters? Well, the investigation would clearly be different with each of these kinds of questions. If you want to really narrow your students' focus, you could ask something like the first question. But if you want to give them options to really explore different ways that design, including the materials used, the friction between the wheels and the surface on which the car is running, or other aspects of the design, the second question might be more appropriate. So consider your question and the kind of data that students will be collecting and what you want them to be able to get out of it when you are posing an opportunity for them to write an argument. If you consider Bloom's taxonomy as a support for writing your questions, you're going to want to get up into the higher levels, the analysis or evaluation or creating levels of Bloom's taxonomy. Let's just consider these questions that are around the El Nino phenomenon. Okay, a remembering or a basic level of questioning might be to ask students, what are temperatures like in the equatorial Pacific during an El Nino? To get up to the comprehension level, you might ask them to explain how an El Nino forms. For applying, use what you know about El Nino and climate to predict where droughts might occur during an El Nino. For the analysis level, why do you believe the National Oceanic and Atmospheric Administration thinks we are experiencing an El Nino? And they'd have to look at current NOAA data to be able to determine that. Evaluating, assess the suitability of the present climate prediction system used by the National Oceanic and Atmospheric Administration. And then creating, design a procedure for determining if El Nino conditions are building. And so students would have to look at the extent and degree of ocean warming, the time of year, what is the level of hurricane suppression currently, how much ocean productivity is it, where upwellings, those kinds of questions. That one gets very complex. So if you're trying to develop questions or ideas that would foster a good argument, you don't want to be down in the remembering, comprehending, or even applying levels. You need a areas that focus on analysis or evaluation or even creating. So these higher level questions really would provide a better foundation for having students create an argument. Because Devon's teacher wasn't quite satisfied with the way her students were developing their arguments, she decided to offer them this template. If you look at the top, it says write an argument that answers the question, can varying characteristic like shape, angle, and size of blades on a wind turbine affect the amount of electricity that is produced? And then she gave students some hints about the claim. Write a sentence to state whether or not varying shape, angle, and or size of blades affects the amount of electricity produced. Your evidence, provide data to support your claim. Use the data from your tests of blade characteristics. For the warrant, explain how your evidence supports your claim. Describe how turbines produce electricity and explain why and how you determined if the data supported the claim. And then for counterclaims, discuss alternative explanations for changes in electricity output. Were any of these part of your data collection? Consider wind speed and angle the wind blows. Why is your claim correct and why are the others incorrect? And by the way, students did use the blow dryers on 2 different speeds, so that could have been a factor in their electricity generation. So this counterclaim makes a lot of sense. So this really supports students to be able to write claims that are strong, that are rooted in all the components of writing a good claim. And as you can see here, Devon's teacher even created a rubric to help students be able to identify the expectations for each of these components of a good argument paper. And this was quite helpful as well. And there are other teaching methods that can support students to write good arguments. Teaching close reading, for instance, helping students to be able to read complex texts using annotation so that they can easily refer to data within those texts. Using text-dependent questions to help them focus as they respond to questions in the text can really build their capacity for gleaning data and evidence from the work of others. You can also provide sentence frames to support the academic language, helping students to say things like the author states, the author supports his claim with, the data reveals, as suggested by the data, as indicated by the evidence. The alternative claim suggests, however, this claim is supported by the following data. These types of sentence frames not only will support students to sound more scholarly, but they will also lead them to inputting the right elements into their argument. Provide opportunities for students to verbally debate ideas. That way they can sort through the claims, the counterclaims with their peers to be able to really come up with the claim that has the best evidence. Have them read pros and cons of issues. Have them regularly write analyses of lab data. And teach them to cite references. In science, the American Psychological Association referencing is the most commonly used. I know that many students learn MLA, but it is also of great benefit to encourage them and teach them to use APA as well. So I want to leave you with these final thoughts. What are you going to do next to facilitate argumentative writing and discussion? And how will you implement argumentative writing into your lesson plans? You will have opportunities to do this.